Hi guys, I'm Hemanth from batch EB06. My topic for seminar is Project Loon. I'll explain the project through PPT.
Hi guys, my topic for the seminar is Project Loon. It's basically expanding internet connectivity with stratospheric balloons. The challenge: billions of people across the globe still doesn't have reliable, affordable access to the internet. The internet has transformed the way the world communicates, learns, governs, and exchanges ideas, but billions of people across the globe lack reliability, affordability access. Loon was a radical approach to expanding internet connectivity. Instead of trying of extending the internet with traditional ground-based infrastructure like fiber optical cables or cell phone towers, Loon took it to the sky with a network of balloons. Loon balloons traveled along the edge of the space to expand internet connectivity to rural areas, filling coverage gaps and improving internet resiliency in the event of disasters. Loon took over 9 years of developing this technology to deliver connectivity from the stratosphere. Loon balloons traveled along the edge of space to deliver internet to the ground below. The journey for this project: we're connecting the unconnected. The Loon team began with a question that could a network of stratospheric internet beaming balloons be the radical idea that might finally bring adult and affordable internet access, not just to the billions, but to the next last billions, to the last unconnected communities and those least able to pay. To explore this idea, Loon started flying out early prototypes through California's Central Valley to see if the idea has promise. In 2013, the team found some friendly New Zealanders who were the first in the world to connect the internet via stratospheric balloons. This early test demonstrated Loon's promise, and after more development, the team built the first LTE connection from the stratosphere to a school in Brazil, showing that it is possible for billion balloons to connect directly to people's phone. Over the years, Loon knocked over one technical hurdle after another, doing these things previously through impossible, like using laser to beam connectivity between balloons in the stratosphere or creating a mesh network in the sky. The journey started out with Scrappy prototype, one of the team's earliest prototype, which is displayed on the left side of the screen. Then they launched at the dawn, were preparing Loon balloons at the dawn for launch in New Zealand in 2013. In 2013, they started flying high in New Zealand. A balloons aloft in the New Zealand in 2013, where they started flying the balloons where you can see from the left side of the screen. In 2014, they started testing in the Brazil by using these Loon balloons to connect a classroom in Brazil. Then in 2014, they started exploring balloon-to-balloon communication where testing free space optical communications in lab. This technology became the basis of Project Thara in 2014. After that, there was a disaster happened in Peru where flooding happens. The Loon team worked to bring ground stations back online to connect balloons after flooding in Peru in 2014. Puerto Rico launch site. The Loon team begins providing emergency connectivity services to Puerto Rico in the aftermath of Hurricane Maria in 2017. After that, in 2020 July, the team delivered internet by balloon connection to the customers in Kenya where they couldn't have the internet connection before in Kenya. To the left side of the screen, you can see the Loon equipment which is used to deliver connectivity in Kenya in 2020. In 2017, when floodings in Peru and a major hurricane in Puerto Rico knocked out critical ground infrastructure, the Loon team navigated balloons to disaster regions and provided emergency connectivity to hundreds of thousands of people. In 2018, Loon became an independent business with Alpha, and in 2020, the team co-founded the HAPS Alliance, which aims to accelerate innovation and connectivity efforts in the stratosphere. In 2020, the Loon launched the world's first internet via based service with partners to the people in unregistered of Kenya. The design of the project. Building a balloon that lasts a long time. The Loon team had a lofty goal, designing a balloon that could last hundreds of days in harsh conditions of the stratosphere, where the winds can reach up to 100 kilometers per hour and temperatures can drop to minus 90 degrees Celsius, all while delivering constant connectivity. The team spent years defining the design and eventually set a record with a balloon that flew more than 300 days before it came down to Earth. Then launching the balloons. While prototyping and refining their balloons, the team were also focused on another big challenge: how to get them up in the air reliably, safely, and quickly. To achieve this, the team designed and custom built auto launchers that they efficiently call Chicken Little and Big Bird. These large cranes were capable of filling and launching a balloon every 30 minutes into stratosphere, high above airplanes, birds, and the weather. Sailing the stratosphere, the team found out various ideas, models, and smart algorithms to find the ways and the directions to the stratosphere. Wind patterns in stratosphere are railed with prevailing winds at one altitude, varying in speed and direction from those at slightly different altitudes. One of the original insights from the Loon team was to take advantage of variability to sail the winds, rather than to fly against them. By designing a balloon capable of ascending or descending to catch a favorable wind, the Loon team could sail through the stratosphere with no propulsion, reaching locations around the world. To identify wind patterns, Loon used advanced predictable models to create interactive maps to the skies. This map allowed the team to determine the wind speed and direction at specific altitudes, times, and locations. The team then developed smart algorithms to help determine the most effective flight paths to varying wind layers. With the aid of these algorithms, the balloons could accurately sail the wind over thousands of kilometers to reach desired location and remain clustered around those destinations in order to deliver constant connectivity below. To the right side of the PPT, we can see diagrams and models and algorithms of the team, where the left side of the diagram tells the predictable model which helps move each balloon into layers of wind blowing in the right direction to our left direction. In the right side, where we can see the software algorithms where a group of balloons cluster at specific region. This information is vitally important for the team to identify the way to go to the stratosphere for the balloons. The advantage of this project are: firstly, one balloon approximately covers 40 kilometers and it would need thousands of balloons to connect the entire globe. This technology would cut the cost and labor of expensive fiber cables that need to be dug deep into the ground. Thirdly, the project Loon would provide humanitarian support to places where there is no access to the common connections network due to restrictions on the free flow of information. Then it can be used to provide internet connectivity even during natural calamity. Lastly, it is very helpful to connect remote areas where traditional internet is difficult to achieve in topographic regions. The disadvantages of the project are: the project Loon has certain limitations as it needs the balloons to be refilled every few weeks with helium. The frequency of maintenance is very uncomfortable. Installation charges of Loon balloons are very high. The entire setup is very costly, ranging around $1.2 million for setup and $30,000 per year for maintenance. The Loon balloons will levitate around the globe, needing maintenance stations across the world, even in remote areas, which would be very difficult to achieve. The Loon is a recent technology that is very high and needing skilled workers that are difficult to find. The cost of the company would be very high after hiring these workers and other human resource teams for the project. What is today's scenario for Project Loon? Despite Loon's extraordinary technical progress, the path to commercial viability proved much longer and riskier than hoped. So in 2021, the Loon journey came to an end. To help further stratospheric research and innovation, the team published the Loon Collection, a catalogue of Loon's technical, operational, and scientific insights. The collections include flight data from all 2100 of Loon flights, including sensor data and electrical measures for scientific and climate research. Some of the Loon's technology, like the high bandwidth optical communication links, first used to beam a connection between balloons moving in the stratosphere, lives on in project for the project Tara. To support ongoing innovations in high altitude platform stations, communication industries, Loon transfers several stratospheric ballooning and network patent to partners working in the similar fields. Loon also made non-assertive pledge for the free using the monitor and other patents related to launching, navigating, fleet management.